Bandwidth for Changelog is provided by Fastly. Learn more at fastly.com, and we're hosted on Linode servers. Head to linode.com/changelog. This episode of JS Party is brought to you by Hired. Hired matches outstanding people with the world's most innovative companies. At Hired, your dream job is waiting to apply to you. Instead of endlessly applying to companies hoping for the best, Hired puts you in control of when and how you connect with interesting opportunities. The best part is Hired is completely free to you. It won't cost you anything. In fact, they pay you to get hired. Head to hired.com/JSParty. Don't Google it. This URL is the only way to double the hiring bonus to $600. Once again, hired.com/JSParty. And now onto the show. Welcome to JS Party, a weekly celebration of JavaScript and the web. Tune in live on Fridays at 3 p.m. US Eastern at changelog.com/live. Join the community and Slack with us in real time. Head to changelog.com/community. Follow us on Twitter. We're at JSPartyFM. And now on to the show.
All right, welcome to JS Party, where it's occasionally a party with JavaScript. I refuse to say weekly since it's been a few weeks. But nonetheless, we're here ready to party. This week, we have a special guest filling in for Michael. That's Myles Borins. Introduce yourself, Myles.
Hi, I'm Myles. I'm a developer advocate.
That's enough. Rachel is also here with us, and this is Alex. Myles, you work on Google Cloud and Node and a bunch of stuff. Actually, introduce yourself now.
I'm Myles. I'm going to take long pauses to make sure that I don't get stopped. I work on Node. I'm on the CTC and TSC.
What are those?
That is the core technical committee and the technical steering committee. I have a slide deck that you can look at if you're interested in learning more about how the governance model in Node works. But it means I'm involved in some of the higher level technical decisions and architecture of the project itself. And I also work at Google on Google Cloud Platform, where I'm a developer advocate. A good chunk of my work is devoted to the Node ecosystem, working on that stuff. I travel around, I talk. And I also work internally with various product teams and engineers to make sure that the products we're making for Node developers are products Node developers want to use. In a past life, I was an artist and a musician, and I'm hoping to find time to do that again in the future.
Yay!
Yeah, that segues well into what we wanted to talk about today, which is some music. So I think between the three of us, we either have dabbled in web audio or are musicians. Or Rachel, what's your music story? What's your music history? You definitely have like at least a lot of cred in old indie bands.
Yeah, so I started out as a web person because I did a website for an online music magazine for teens. So my first concert was Warped Tour in 2001 to go and interview bands like Good Charlotte and
NoFX.
Not NoFX. I've never interviewed NoFX, but
Well,
I definitely
Goldfinger.
I have not interviewed any ska bands, actually.
Oh,
I've
wow.
only which Goldfinger's questionably ska, I guess, but I've interviewed a lot of pop punk bands. And I interviewed Newfound Glory and, 311.
Hey, 311 was my favorite band for a long time. The drummer's name is Chad Sexton. Unrelated, but I'm also a drummer. So.
Oh.
Whoa. It's not that big of a deal. He's good.
Hold on, sorry, my cat.
I'll translate. Her cat.
I think I understand. Rachel, you want to mute and we can keep going?
I'm all right. Sorry, my cat was on my lap and he jumped off and his foot got caught on my headphone. And yeah, we're okay. Go ahead.
Yeah. Okay. Speaking of NoFX, there used to be no way to do music sound effects on the internet. But Sorry about this segue in advance or in retrospect, but Myles, you've done some audio API stuff. Is that why you were interested in talking about it, or you just want to talk about music?
My first larger web app that I ever wrote was actually an accessible keyboard, and I've been hacking around with the web audio API for, I guess, going on 5 years now. That's how long it's been since I first started hacking on it, though, not like a measure of the total amount of time that I've devoted to it.
Sure, a solid, unrelapsed 5 years of pure time. So is that your only project? So you have a keyboard. It like I assume like on your keyboard you pretend like you're playing a piano and then it makes the sounds in the browser?
Exactly. The thing that was neat about it was that it was built with this JavaScript framework that was all accessibility first. So the website actually had no instructions on how to use it unless you were using a screen reader. And if you were using a screen reader, it had a full in-depth tutorial on how to use it. It also had an exposed API, so you could change what A4 was, like so what the frequency of A4 was.
In case you're a 432er.
Yeah, and it also allowed you to change how many steps you wanted to break the octave into, and then would distribute keys appropriately. You could set up patterns and start arpeggiating, and then like start playing the musical canon instead of the notes, which was a fun little hack.
Yeah, that's great. That's pretty cool. I'd be actually really interested in seeing that. Does it still exists online?
Yeah, it's on GitHub. I have no idea if it still works, but it's called the Automagic Music Maker.
Yeah, that's cool. There's a fun story about Prince. There's like a whole like cult of people who think that middle A shouldn't be 440, it should be 432. And they'll show you all these like cardioid graphs that look way prettier than the ones at 440, and I like see the math works out to be more beautiful visually, so it's got to be true. But a lot of people thought for a long time that Prince detuned his guitar to E flat instead of E, but it's actually not quite E flat. It's E, but in the like tuning of where middle A is 432 instead of 440. Just some fun Prince facts.
Oh yeah, that's amazing.
Yeah, a lot of his like better tone. A lot of people tune down to E flat just to get. You can play thicker strings because they're a little looser, and so you can have kind of fatter tone. And so a lot of Prince's well-known guitar tone comes from the fact that he detuned his guitar essentially, and then was able to kind of play fatter strings and stuff. Just fun, normal JavaScript Prince trivia. The other interesting thing about your explanation was I forgot your of the origin of Canada. Yes. Yeah, the JavaScript always
came out.
Gives it away.
Myles, I feel like Myles is secretly Canadian because he doesn't. When I first met him, I didn't know, and he kind of was like a little quiet about being Canadian.
Am I supposed to introduce myself that way? Hello, I'm Myles. I like maple syrup, and it's called pay meal. Thank you.
I'd actually
would you like
flip it around to where
Caesar?
you start there and then say your name.
Yeah, that's how it goes. Usually we know when you say JavaScript, so.
I'm changing my Twitter profile. It says Canadian Myles now.
Canadian Myles. How do you pronounce the library that is the most popular for transpiling ES6 into ES5?
Oh, are you talking about Babel?
I am. Did you change the way you pronounce it?
So I did say Babel at first, and then I was corrected by Seb. I then proceeded to send him a whole bunch of photos of the pig Babe, which I'm not sure if he appreciated.
Wait, is it Babel? Because I say Babel, but I've heard a bunch of other people say Babel.
It's mostly Canadians that say Babel.
Oh,
but Wes Boss does all the tutorials, and so a lot of people come across the term Babel for the first time from Wes, and since he's Canadian, they hear Babel for the first time, and then they repeat it mindlessly, which is not what America's about, right? So
I think that's actually where I heard it, which made me question everything that I knew or thought I knew.
Yeah, I mean, shout out to Wes for making people question everything they thought they knew. Well, cool. I feel like we didn't get very deep into the audio APIs. Rachel, have you done any web audio stuff?
I haven't yet. I actually know nothing about music. I took piano for 2 years and that was about it. So I haven't, but I've seen a lot of people do really, really interesting stuff with the web audio API. Before Myles, I've seen Myles do some really cool stuff with spatial audio, which I'm sure he'll talk about a little bit more. But I've seen some other really cool examples of people using the web audio API with CSS and doing orchestral stuff with the spatial audio. But for me, I don't really know anything about sound, so I haven't played around with it yet. No.
Myles, tell us about the spatial stuff.
Okay. Do you want a 5-minute version, a 2-minute version? I can talk about this for hours.
Yeah, I mean, just start going and I'll cut you off whenever everyone's asleep.
So there's a handful of different ways of doing spatialized audio. The most often used one is what's known as binaural, and that's using what are known as HRTFs, head-related transfer functions. An HRTF, or a transfer function, is a black box that can take some data, output some data. It's a pure function. It's some math stuff. But basically, with an HRTF, you can take an audio signal, you can put it into the HRTF. You can give the HRTF a handful of tunings, and it will give you back an audio signal that is spatialized. So the web audio actually has some HRTFs built in. They are not super accurate. In general, you kind of need an HRTF to be tuned specifically for your head and your body. They're called head-related because of how our brains place sound in space. So
would you, in order to tune one, do you need one of those microphones that looks like a head, or do you have to put microphones in your ears, or how does that work?
So you can tune it by sitting in an anechoic chamber, which is a room that's designed to have no echoes, putting microphones inside of your ears, or wearing specific kinds of headsets, which will then create a whole bunch of different sounds in the room and measure the filters of your body. So your ears are really good at determining if a sound is far away by how loud it is, and if it's to the left or the right of you, based on how much energy is in each ear. But being able to tell if it's above you, behind you, in front of you, below you, all of that's actually based on the filters of your body and the way it filters the sound, and your brain just knows that because it's kind of always hearing it that way.
I'll interject some interesting information that I have a project studio at the house. The rooms that you see, when people mix in rooms, they have all the sound foam and stuff like that on the walls, and those are to prevent early reflections. And so your brain has a hard time discerning between the straight sound from the speaker to your ear and then the sound that goes from the speaker off the wall to your ear, because they happen so close together that it feels like the same sound is just mushier. Whereas a sound that bounces off a wall 30 feet away and comes back, your brain is oh, that's clearly an echo or a reverb in the room, and it's not part of the original sound. And so tuning rooms is really important because you want to remove all of the early reflections that would cause some of that smearing to happen. But the way that people have existed for a really long time, and so we actually are better at discerning early reflections off of the ground than we are off of walls or ceilings, which is really interesting to me. So your brain can kind of know if the speaker has a sound, it bounces off the ground and gets to your ear, it can do a lot better job of discerning the difference between that than off of a wall, from the side, which is just kind of magic to me. But it makes sense because there haven't been walls for that long of human existence. So evolution would maybe kind of cover it. Anyways,
I want to expand on that a little bit, though. Something that's just a thought experiment that I always found really interesting. So, sound comes out of a person or out of a speaker or something, and it reflects off of surfaces. Each time it reflects off of a surface, it decays a bit. And this is a way that you can just think about filters in general. It's like a change in amplitude or a delay. So as the sound bounces around the room and each time it reflects, it decays more. And generally, that decay is happening in an exponential curve. But mathematically, would it ever actually reach zero? Or is sound infinitely decaying and it's just at kind of like sub-perceptual levels? And are we constantly surrounded by the infinite sound of eternity?
Yeah, it's whole the go halfway to the wall, infinite amount of times and you never reach the wall type thing. Yeah, it's I do like the idea of that. It can sound. It kind of makes you wonder, like, are we surrounded by it, or does sound eventually, like you know how you on a screensaver you wait for it to finally hit the exact corner. I guess that was The Office. Like maybe sound eventually hits the ground at the exact perpendicular, like direction in order to escape the Earth, right? So it still exists, but it's no longer surrounding us. Maybe. Could be. Maybe the atmosphere bounces it back in, though. I wonder if the atmosphere has sound bouncing. These are all interesting questions that are probably too far outside of the bounds of web audio.
So I actually want to interject for a second, because I've seen a lot of, proof of concept demos for what people can do with the web audio API, but I don't think that I've ever actually seen it in actual use. I guess mostly because I've only seen like artsy demos and stuff, but in terms of like practical application, I'm thinking of like, obviously this is going to have a big space with like AR and VR type applications, but what have you two seen that utilizes it in an actual practical in-use sense?
I'm not sure I can think of. I guess there are games, like legit games, not just like demos, that I've seen that use the web audio API. But as far as just like business product, I don't see a lot of web audio API in those.
So I was recently visiting ERCOM, which is a music technology research facility in Paris. And they actually have an entire team that is building interactive installation work and interactive web demos, and it's all built on web technology. So one of the examples that I saw that was particularly interesting was this like DJ app that they had. It had a native component to it to hook into Bluetooth, but essentially you would have a loop on your phone and you would have headphones on, and when you got close enough to someone else in the room, your two phones would find each other on Bluetooth and your two things would sync, and then you would be like playing music together and make impromptu dance parties throughout the room. And the entire the entire audio engine was all web audio for that.
That's pretty cool. I'm thinking now of like, what is Spotify written in? Because Spotify isn't just like Spotify's a web app that's like wrapped in something, right?
Right, but well, to some degree, but it's a little different. Like just playing a song is like almost to the point of like maybe they use the web audio API to do it, but it's not like they're not using the web audio API for anything other than like play, pause, start, stop. They're not doing like compression or sound leveling or like any of their actual like transforms on audio in the client. I don't think that I've seen at least.
So what exactly is the web audio API?
So the web audio API is an implementation of an audio graph. It gives you nodes that you can use to create sound and to modify sound. It uses abstraction that's called unit generators, which is an abstraction. This kind of audio graph unit generator approach is one that you'll see all over the place in audio programming environments and under the hood of a number of like popular audio software. It's how the programmers of those are implementing it. So you'll have a node for the output. You'll have a node for your microphone. You'll have a node for a delay line, and you can connect the microphone to the delay to the speakers. and it will, do its thing. And you can add graphs and remove. You can add and remove nodes to the graph, and you use a combination of various unit generators to create different effects and different synths and different audio interactions.
So you can have audio being generated. Can you use the same modifiers from non-generated audio, like audio that's just being sourced from an input or something like that? Like a guitar. Can you write like I've seen? I'm pretty sure it was a web audio API, but there's a JSConf.eu from a few years back where you did like guitar stomp boxes and stuff like that. Is that the web audio API? Or is that something different that I don't think you have?
Yeah, that would likely be the web audio API. You
Cool.
could take an external input and run it through any number of filters.
Okay, cool. And you can write your own filters and build a grunge box and a delay pedal and all that kind of stuff.
Mm-hmm. And you have primarily two different ways of doing that. You can do that by either using the variety of nodes that are provided for you in the API, or you can actually write your own unit generators using the script processor node. As far as I know, the script processor node has been deprecated, though, and there's like some real problems using it for sample accuracy because there's a time delay between sending messages to the node and getting the samples out of it.
I see. Yeah, the DSP is all about latency at some point.
Mm-hmm.
Yeah.
I'd done some experiments with early ASM.js and compiling the Faust signal processing language to the script processor nodes.
Oh, wow.
And we were actually able to get like really, really intense analog amplifiers with like nonlinear, like all sorts of like really fancy stuff running at near native speeds in the browser. And the major issue is not the ability to process, but like the 10 to 14 milliseconds you would have in delay going to and from a script processor node.
Right. All the platform delay, not the actual code. That's interesting.
Mm-hmm.
The nice part about that though is that like it shows that it's possible in the future to fix. It just doesn't seem like it's a priority. That Mozilla for a long time prioritized a lot of web audio stuff, and I think they have some of the only like built-in tooling to be able to kind of modify it. Does that sound correct? Is that what you used?
I never used those tools, but they did have like developer tools specifically around viewing the audio graph, if I remember correctly.
Right. Yeah.
And there is spec work being done right now on an audio worker node, which would work more similar to web workers. And I believe they might even have access to shared array buffers, which would solve the delay issue, although it would now create the complexity of multiple things, maybe. Yeah.
Yeah. You trade one for the other. Well, cool. I look forward to the day when I can load VST plugins into the browser and just go for it, which doesn't seem too far off. I imagine WASM even takes the distance between the native stuff even closer. So it seems like getting those nodes to have zero latency or whatever seems to be a priority. I'd be interested if anyone wants to follow up, if there's like work, is the worker the solution that we're going to go with, or can we make the current ones faster? Let us know.
This episode is brought to you by TopTal, a global network of top freelance software developers, designers, and finance experts. If you're looking for contract or freelance opportunities, apply to join TopTal to work with top clients like Airbnb, Artsy, Zendesk, and more. When you join TopTal, you'll be part of a global community of developers who have the freedom and flexibility to live where they want, travel, attend TopTal events all over the world, and more. And on the flip side, if you're looking to hire developers, designers, or finance experts, TopTal makes it super easy to find qualified talent to join your team. Head to TopTal.com, that's TOPTAL.com, and tell them Adam from the Changelog sent you.
Okay, next we're going to talk about, I think this is a little bit of a jumping off point. There was a fun issue lodged on the TypeScript repo that claimed that TypeScript was Turing complete. And there are some people with some requests for mathematical proofs, but he had a pretty compelling example where all he did was add types and then was able to get like a prime number figure out of the like type checking. And so I think he was mostly saying, if you stop the recursion part of this, it'll stop. But it's just kind of a funny issue that like you add enough complexity in your type system on top of your language and like suddenly you have another Turing complete language on top of your language. But I don't know if there's too much to talk about from this. What have you guys ever seen like the Turing complete CSS like games and stuff like that?
Yeah.
Do you know how those work? Can you explain it?
No, I don't know how they work.
Cool. So it always like requires input. There's like, if you haven't seen the CSS games, like the most simple example of like CSS that works in a way like a program would versus one that works in a way that like styling would is like a slideshow. So if you think about checkboxes as having a style around checked or unchecked, you can kind of like put a giant transparent checkbox on either side of a slideshow, and whenever you check a checkbox, put one between each slide, you can kind of say, show the slide that is the sibling element, the next sibling of the selected checkbox, and then you hide all the checkboxes to where they're transparent but on top. And so you essentially build this whole slideshow that has no JavaScript, but every time you click the next, hidden checkbox, it shows the next slide, because now the next slide is the one that's the next sibling of the thing. And so like you can kind of see how you can take JavaScript out of the equation by using this one cool trick to say that, like do something based on the active checkbox. But you can actually do the same thing to like make a game. So tic-tac-toe is an interesting one to where you can theoretically, make checkboxes that have X's or O's, but you can make the game have a win state, like say you won, if it detects any of the potential win states as like, you can imagine like a selector that has the selector for all possible combinations of 3 X's in a row. And so like people can make tic-tac-toe based solely on selectors. And that's kind of like making games that rely on no JavaScript. And there are much more complicated games than that.
So like, isn't the majority of the time that like people make the Turing complete CSS projects is to like refute the notion that CSS isn't a real programming language?
Yeah, I think that it's more just for fun. Like definitely no one is suggesting that people should use CSS like this, I think. Like the slideshow is maybe a good example of something that could work, but the tic-tac-toe is unreasonable. And I don't think anyone's saying that it's the ideal situation.
So I guess, what is the importance of having a language be Turing complete? I guess it's just another abstraction that's Turing complete in regards to the issue that we're talking about. But like, what is that? What is the importance of that, I guess, necessarily?
Yeah, I wouldn't say that there's an importance. I think it's more like exploration is fun. And I think the person who wrote the issue did a good job of kind of making light of the situation and saying like, no one cares about this. This is just a funny thing. Maybe you could turn it off like this if you didn't want, because it like in this case it came along with the problem where you could accidentally create infinite loops of type checking. But I think more than anything, it's just like a fun exploration of like taking a technology to its limits and exploring areas of it that like weren't for an intent, but then being able to do like crazy things because of that. Other things that come to mind are like using there's a language called JS fuck. You can bleep that later. But it's like completely based on the fact that arrays cast themselves into integers, and then it'd be insane to explain it here, but yeah, go ahead.
That's just an abstraction of the SOLang brainfuck, it sounds like. I don't know if you're familiar with that.
Yeah, I am. It's not. It's similar, but it uses very specific properties of JavaScript to where it can kind of bootstrap itself by grabbing letters off of prototype functions and then evaling them, all based on like positions in arrays. So the it's very interesting looking, and it doesn't really work the same as the other one you mentioned, but it is very similar in its incomprehensibility. But everyone should check it out. But I think it's just a good example of like doing something entirely unexpected with a language, and like it falls into the category of uselessware that I think you and I have talked about, Rachel, before, at least on Twitter, maybe, of just like building something for the sake of like saying this is cool and fun and weird, but no one should necessarily like do this for their job. Right. Yeah.
I mean, I think it takes a like certain type of person that has a full grasp, like a full, like down to the nuts and bolts grasp of a language to be able to even like get down into figuring out that kind of stuff. I mean, at least from my perspective, as someone who does not have a full grasp of language. Not even English, like, let's be honest.
Yeah. Sorry, I was saying yeah to myself. The yes, you are bad at English, Rachel. I do find it really fun to like try to get so deep into some topic to where you can kind of flip it on its head, break the norms, and do something interesting and cool, even if like there's a reason why it's not the norm, because it would be a terrible idea. But just kind of like take everything to its logical maximum, to where like theoretically we only need 3 characters in JavaScript to run any program, which is a cool idea, and I'm glad that someone like wrote a compiler for it and we can talk about it on a show. But like I don't anticipate anyone actually using it in their application. For one, it would break all my CSP rules. Myles, can you think of this is a little bit on the spot, but can you think of other things in this vein? I know you tend to not gravitate, but you tend to be associated with a lot of projects that do similar like for instance, making a piano that has a tunable middle A and random intervaled or programmable interval keys is a good example of like kind of breaking outside the norm. I'm trying to think if there's other things.
So can you just give me a tiny bit more context? Which norms are we talking about? Are we talking about language norms or?
Yeah, so I'm just trying to find more examples of this stuff. So the situation with TypeScript is we have a thing where someone wanted to add like, all right, we want to type check integers in these places, and it's like, okay, now we have more complex types and we want to do this and this, and eventually you have such an amount of complexity to where you can kind of do a whole programming language out of the thing that it's supposed to attach to your programming language, and it's a fun game to play. But I don't think anyone's going to be programming in TypeScript types anytime soon, if that makes sense. This is, I think this question's potentially just a bad question. Do you have any thoughts on the topic, I guess?
So I think that I know what you're going at here, which is like the beauty of combinatorial complexity.
Sure.
So like, it's really, you see this happen a lot. I'm going to bring it back to audio because I'm in that mood now. But like you'll see this happen a lot in like algorithmic composition, or any sort of like generative environments, where you get things that are really interesting is like you may have one thing that's like repetitive and it's in like the randomness that it gets interesting and in overlapping randomness. But then when you actually make like the ability to program that, so like a really good example would be, I've seen a performance where there's like 4 or 5 different voices that are playing, and they're playing different patterns, and each of those patterns have a randomness value that can be added, that will randomize the patterns, and this performer mapped that to a fader. So you can make it more random or less random. And so the way he would do his performances would be kind of put everything out super random and then slowly dial it in to the point where it like reached a stable state. And so I think that's kind of what you're talking about, is where like you create this combinatorial complexity. Within this complexity becomes these like new higher level attributes that you can work with, and then you can use those as the means in which you program. And I think you see that happen a lot in like environments like Ableton or like other kind of programming music environments, where you're no longer like worrying about the notes that you're playing, so you can focus on playing like other aspects of the song, such as like, you know, the timbre or like playing with compressors or just like effects and stuff like that.
Right. Yeah, I think it's for a tough question that I asked, that I think that's a good example of kind of like just taking the side effects of something and using that as kind of your core. It's like someone allowed randomness for one purpose, and then you take randomness and now you're making randomness the core ability, like the core thing. Kind of like types were the point, to enforce against this language, and then you're kind of taking them and like literally just throwing away the language under the covers and only using types, and kind of using like starting from that new baseline. I think it's a thing that kind of again is always going to sit on the fringe, but I think it's an art, just like that person kind of created art out of the randomness is, and I think noticing things and doing like the CSS games and all these like edge case situations, I think is kind of definitely falls in the realm of beauty and art and creativity in a way that is super interesting to people. It's similar to like I think it's called like one div, a single div. Is that a thing?
Yeah. Oh, who did that again? That was such a beautiful project from Andia.
a.singlediv.com. I'm gonna go ahead and start into the projects of the week, or the picks for this week, and my pick this week is going to be a single div. So a single div is an interesting website to where CSS developers get a single div, and they create like icons and pictures and cartoon characters and scenes and all sorts of stuff, all with just like after content like type tricks in order to make a single div turn into like an infinitely scalable, beautiful little picture icon type thing, and they're extremely impressive. Lynn Fisher is the person who made that.
Cool.
Rachel, do you have a pick this week?
I do, only because I asked someone for suggestions and they gave me a good one.
Nice.
Full transparency. So there is this project that came out this week called Stack Blitz that is an online VS Code IDE for Angular and React. I just hit my microphone. Sorry. Basically, it lets you create Angular and React projects that are immediately online, so you don't have to push anything to production or rely on any other kind of thing. It just lets you code, and it installs the dependencies and does magic, and then it's there. So if like Angular and React are your thing, I figured since we talked about TypeScript a little bit earlier, this was a nice pseudo tie-in. You can give that a shot.
Myles, I'm potentially putting you on the spot, but do we tell you to try and pick something ahead of time? Or do you have anything in mind?
I do just-in-time picks, and I've got it just in time.
Cool.
It's a GitHub repo called Omnitone. It's from the Google Chrome org. It's a library for doing spatialized audio. So it's built on a lot of the stuff that I was talking about earlier. It's a robust implementation of a first-order ambisonic decoder and a binaural renderer, and it allows you to take spatialized media and play it and rotate it and play it through virtual speakers and then to actual physical speakers in a headphone. And the thing that's really cool about it too is if you're doing any stuff with WebVR, you can use this in conjunction with WebVR to do spatialized audio that will actually move around with the movement of your viewer.
Nice. That's really cool. Well, this episode got into the weeds a little bit more. Myles and I tend to be bad at staying on topic. So I don't apologize. Hopefully you enjoy one episode like this, and hopefully Michael can be back and ground us a bit in the future.
Better than nothing. It's better than nothing.
Well, let's not get ahead of ourselves.
You all realize you're basically apologizing and saying that I'm better than nothing, right?
No, I said let's not get ahead of ourselves. But thanks for listening this week. This has been JS Party.
All right, thank you for tuning in to JS Party this week. Thanks also to our sponsors, TopTal and Hired. Also, thanks to Fastly, our bandwidth partner. Head to fastly.com to learn more. We host everything we do on Linode servers. Head to linode.com/changelog. Check them out, support the show. This show is produced by myself, Adam Stakoviak, and edited by Jonathan Youngblood. And the awesome music you've been hearing is produced by the mysterious Breakmaster Cylinder. We do this show live every Friday at 3 p.m. U.S. Eastern, noon Pacific. So join us at changelog.com/live. Slack with us in real time. Head to changelog.com/community. We'll see you again next week. Thanks for listening.